Multiple images. Let's take a look at this. Protection plan, no, I'll pass on that. I've got to be within a budget. Here are a bunch of accessories. Speaker, microphone thingy, $26. That's not bad. What else is on here? Oh, the interface cable. That would be really handy. In fact, I think I'm going to go ahead and do that, and I'll explain why. The shipping policy of DX Engineering is that when the price exceeds or is greater than or equal to $100, they do free shipping. So I think what I'll do is go ahead and order this. DX Engineering is really good in getting it out, even though it's late in the day, local time, 6:30, and they're closed. If I put in the order, it'll be here tomorrow. Also, I want to transmit with it without changing the setup here and see what the output looks like. Does it overload the front of the Tiny SA? That was another thing that people were critical of, and they're good comments, and that's a good question, and some didn't like the system that I used for testing the handheld. In the past, I transmitted into a dummy load through a device that I built that siphoned off just enough RF to get an indication on the Tiny SA, so about 30 dB of attenuation. The results were basically the same. I'm doing it with a handheld and the antenna because that was suggested by several about a year ago when I did some testing, because that would be real world transmitting. You are not going to transmit into a dummy load and communicate with somebody. So I'm doing it and have done it with the antenna that's supplied in a real world situation and a receiver that maybe isn't all that far away, but keep in mind that some of the handhelds that I tested, in particular the Yaesu, the H8, and one of the H3s, I think, they were all reasonably clean. So let's look at when this thing gets here, open the box, plug it in, charge it up, and see how it looks. Is it clean? Or was my experience with the other Yaesu transceiver unique to that transceiver? So stand by next time you see me. You'll probably see a handheld in my hand, and we'll be testing that Yaesu, which will come from DX Engineering out of their warehouse in, I think it's in Nevada. All right, stand by. In the blink of an eye, I'll be right back. All right, I said I'd be back the next day with the Yaesu handheld from DX Engineering. DX Engineering did get it delivered early in the day, actually, by UPS out of Arizona. But I owe you an explanation. It's now about 3 days later because I had to go to the emergency room at Kaiser Roseville. Spent a lot of time there. Tests were done in oncology, and some other stuff went on. And if you would like me to explain what's happening, I'll do it. Back to this. So here's the FT4 handheld. Comes with a battery, stand-up charger. It's a nifty little radio and $95. It seems to be. It's got a bell clip that I haven't put on yet. Easy to use. Memory system is easy. VFO or memory channels. It's a great little transceiver. I did buy the programming cable for it. I probably already had one, but that was another $20. The reason for that was at $95, I pay for shipping. At $100, DX Engineering pays for shipping. So I was able to get the programming cable included with this, and so I didn't have to pay the $15 in shipping charges, and that pretty much covered the price of the programming cable. So shipping charges were zero. So let's turn on the Tiny SA. Many thought that the test wasn't fair because I was using the handheld with the attached antenna. In the prior tests, a lot of people said that my test wasn't fair because I was transmitting into a bird dummy load, and I should be transmitting into the supplied antenna because it would act in a way to filter out harmonics and others. So I've done it both ways. I'm going to continue doing it the way I did it earlier, and that's with the antenna attached. Some said I overloaded the front end of the Tiny SA. That's an interesting comment. This is 5 watts, and I have a 10 watt transceiver here too. If the 10 watt doesn't overload the Tiny SA, then I don't think the 5 watt ones should either. So I think my test was fair. Let's look at the TID Radio H3. Okay, here's the Tiny SA, 145 megahertz handheld, and let's see what it does when I transmit. The Tiny SA is on, it's sweeping, and there you go. So here's the TID Radio H3, and it's got some harmonics. So we're back to the Yaesu, and we'll look at that again. Pressing the push to talk after I turn it on. And it's down about 10, 20, 30, 40, 50, more than 50 dB. So it really is clean. The price of the handheld included the stand-up charger, power supply, radio, antenna. There are a lot of nice features in that one. I don't think it's a whole lot different from the TID radio. And I don't believe it can be programmed to transmit on frequencies not assigned to us. So which one would I carry into a command center during a disaster? It would have to be a name brand, like a Yaesu. And in the past, when I did that, it was an ICOM. I had extra batteries, extra antennas. I had everything you could think of in case something went wrong, because sometimes it did. Anyway, got really good comments. I think it's like 300 plus comments the last time I looked. Most of them were incredibly friendly and made suggestions about how to do things in a different way, but I had already done them in that different way with a dummy load. Anyway, let me know what you think. It's been a fun project to test these things. All right, thanks for watching. If you haven't subscribed, please do that. I would appreciate it. It doesn't cost anything. And if I can get the number of subscribers up, the video gets viewed more often. For now, 73 from Jim, W6LG in Rocklin, California. Bye-bye.
I was inspired to do this video after being a guest co-host on the Dinosaur Den with Bill Hurd. If you haven't seen that video, I'll put a link down below. Bill and I spent about an hour talking about some vintage test equipment, so I thought it was time to bring out this vintage receiver. This is a Drake Model 2B communications receiver, primarily a 80, 40, 20, 15, and 10 meter ham band receiver, but has additional crystal sockets that allow you to tune it in on other bands. I picked this up at a Hamfest over the summer. I've yet to power it up because we really need to take a very careful look at the radio inside and out to be sure there aren't any obvious problems before powering it up. And then we're also going to want to bring it up very slowly on a variac to potentially reform any electrolytic capacitors that might have kind of gotten soft on us here. But before we do that, I thought it'd be fun to just take a quick look at the controls on this receiver, and then we'll take a look inside and see what this thing looks like. The receiver has a preselector. A preselector is a bandpass filter that's right at the front end of the receiver to ensure that we reject any signals that are outside of the band of interest that we want to tune in. And this helps prevent receiver overload from, say, maybe a strong signal on 15 meters, affecting our sensitivity on 10 meters, for example. So it really allows you to kind of pre-tune a particular band before we go in and tune a particular frequency to listen to a signal. Okay, down here is the band selector to allow us to select which band we want to tune in and listen to. RF gain to control the gain in the receiver. The passband tuning here allows us to select the final IF bandwidth, 3.6 kilohertz, 2.1 kilohertz, or 500 hertz, depending on the mode that you want to receive. One of those will be appropriate. And then the vernier control here allows us to essentially shift that final IF essentially up or down in frequency to really help eliminate close-in adjacent signals. So a really nice feature that was kind of uncommon in receivers of this vintage. AF gain is obviously our volume control and our main tuning knob here. For the switches, obviously power on and off here. This is the optional crystal calibrator that will allow you to basically generate a signal every 100 kilohertz so that we could kind of line up the dial pointer with a gradical line. And once you get kind of zero beated on one of those 100 kilohertz spurs, you literally just slide the dial back and forth to line it back up again. And that's kind of how you calibrated the dial on these things. The receive and standby switch is that's when you're using this in a station where you've got a transmitter. You throw it on standby to mute the receiver while you're transmitting. When you're finished transmitting, you put it back on receive. The next switch here selects the fast or slow automatic volume control circuit. Basically, it's kind of automatic gain control type of a thing. And again, depending on the mode, fast or slow would be appropriate. The next switch is a noise limiter, most often used when you're using the diode detector. The detector type is either selected for diode or product. The diode detection is useful, for receiving AM. The product detector is useful when receiving single sideband or CW. And then the beat frequency oscillator, you would turn that on when using the product detector to essentially reinsert the carrier into, say, a single sideband signal so that you can receive it. So these are our basic controls. Let's take a look inside to see what kind of shape the receiver is in and see what we're going to be up against in trying to bring this thing back to life. I've taken the receiver out of the housing, so let's take a peek around the back here, the top of the chassis, to see what's going on. A really neat copper plated chassis, which is kind of cool. Receiver's a little bit dirty, a little dusty, kind of a barn find, if you will, but it looks complete. Even has here, this is the optional crystal calibrator that was not included in all of the receivers. That was an option. The fuse is here. Looks like all the tubes are in place. The dial cord is in place. A little dirty and dusty here. All of the main crystals for the main ham radio bands are there. There are no optional crystals in for bands A through E, so they're not there. But otherwise looks pretty complete. See, the terminal strip here is broken off of the end, but it looks like just the antenna screw is the one that's broken off, but we can always use the SU239 connector here for the antenna. And we don't have the Q multiplier. But otherwise, from the top here, it does look a little dirty, but complete, so that's good. I'm just taking a look from the other side of the chassis here. We've got some of the adjustment coils for some of the main ham bands to align the receiver. Okay, I just noticed something here and looking at this, that this wire coming up here to this dial light, the insulation is all melty off of this thing. It looks like this wire's been cooked. And what I suspect happened is that maybe this the bulb here or something shorted against the case and maybe just drew a lot of extra current, but this whole wire, the insulation on it, is all kind of melted and in bad shape. So that's definitely going to have to be replaced before we try to power this thing up. Okay, turning the unit up on its side here so we can take a look underneath. It looks to me that the radio is original. I don't see any real modifications or any changes. It also looks like the original electrolytic capacitors are still in place here. They've not been replaced. So we do have to be very careful in powering this thing up to be sure we don't explode any of those. We'll try bringing it up on a variac when the time is right. But in looking at this here, I can see the evidence of that same problem that we saw up top. That we look at this wire here, we can see the insulation is kind of melted off it. You can see some of the bare wire hanging out right here. And that wire is coming from, and then if we trace that back, it's also melted up here, and this is coming from the filament transformer. So this is essentially going to the filaments of each of the tubes. So we've got one here, it's going down to here, and then from there we keep following it, and I can kind of keep seeing that same melted wire all the way through. So we're going to have to follow that wire everywhere it went and replace that. Get rid of all the melted wire to be sure that nothing is shorted against anything before we even attempt to power this thing up. But anyway, other than that, the radio looks like it's in pretty good shape, complete, and not kind of hacked up. So I'm kind of hopeful that we can eventually bring this thing back to life. So I think I'll get busy at least replacing that wire to kind of get started with and do a little more thorough inspection. And then maybe we'll try to bring this thing up on the variac. But maybe that'll be a topic for a follow-on video for this. But so just a little bit of a teaser to take a look at this 50-year-old receiver and kind of how they made them back then. And maybe in some future videos we'll show bringing this thing back to life. Thanks again for watching.
Lima Golf. Calling CQ, hello CQ. CQ calling CQ, hello CQ. Whiskey 6 Lima Golf. Whiskey 6 Lima Golf.
Hi, I'm Jim, W6LG for Ham Radio Basics. Welcome to my radio room here on Wolf Mountain. Ham radio operators are meter readers. They read play current meters, grid current meters, screen current meters, SWR meters, field strength meters, watt meters. Speaking of watt meters, the most popular watt meter ever, and the one that is the standard of the industry, is the Bird 43. And that's what those are. The Bird 43 has been around since the 1950s and really hasn't changed much. Well, the price has changed a lot. They're pretty expensive these days. But they really are the standard of the industry. If the FCC visits a facility, the guys likely are going to be carrying a Bird 43. Bird 43s have an interesting design. It's interesting because it's so simple. Basically, in the metal case, there's nothing. There's a 0 to 50 micron meter. It's a rugged meter. And the other thing that's in there is a metal coaxial cable with a hole in the side of it. That hole accepts slugs or elements, and elements come in a series of values. For example, out of my case of elements, this one is, without my glasses, 0 to 2500 watts, 2 to 30 megahertz. This is handy for a couple of reasons, in that the